Good morning, guys. So I was starting to take a look at this worksheet, and I decided there's some parts of this that are rather difficult. So I would like you to try each question on your own and then kind of watch the video to make sure that you're doing it right. So Grant has 310 square centimeters of wrapping paper. Does he have enough to cover this package? Show work to justify your answer. So this is probably the easiest one because we've talked about wrapping a box all the time. So wrapping a box is surface area. So we need to find the surface area of this rectangular prism. Remember, the easiest way to do this is do the smiley face method whenever we have rectangular prisms. And since we're covering the whole thing in this case, that'll work because you'll see some on this video don't cover the entire package. So I'm going to take my numbers. So I have 6.5, 6.5, and 20.5. Remember, smiley face method works like this. So I'm going to say 6.5 times 6.5. That gives me 42 and 25 hundredths. Then I'm going to do 6.5 times 20.5. That gives me 133 and 25 hundredths. And then again, I have 6.5 times 20.5, and we already did that. We know it's 133 and 25 hundredths. So I'm then going to add those all together. And I get 308 and 75 hundredths. But remember, that would be only covering 3 faces, and there's 6 faces, 2 identical of each. So I'm going to take this and multiply it by 2. And I get the final answer of 617.5 centimeters squared is what he needs. And the question says he has 310 square centimeters of wrapping paper. Does he have enough? So my answer to the question is no, he does not have enough. I think it's supposed to be a trick reminding you that if you don't just add them, because here when I have 308, you might say yes, but remembering that you have 2 sides of each. So be careful there. Julia wants to paint the walls of her regular shaped room. If 1 container of paint covers 10 square meters, how many containers should she buy to finish the job? Show your work and justify your answer. So showing your work is justifying your answer here. So a couple of things. Some of these numbers are hard to read. This is 2.5. This is 3.5. I think you can see the point there. So remember that when you're covering walls, you're not covering the floor and the ceiling. It's just your 4 rectangular walls. So I'm not going to use the smiley face method here because the smiley face method would include the floor and the ceiling. So I'm going to look at the different rectangles that we have for the walls. So one rectangle would be this one right here. And that's going to match this one up front. So how I'm going to do this is I'm going to do my first rectangle, and I'm going to say O because I colored it in orange. And I see that rectangle is 2.5 by 3.5. So I'm going to multiply those together. 2.5 times 3.5. And I get 8 and 75 hundredths. But I don't just have one of those walls, I have 2. So I'm going to multiply that number by 2. And I get 17 and 5 tenths for my orange walls. Okay. Then I have these walls on the sides. I'm going to put in blue. Okay. So I'm going to say, all right, then I have these blue rectangular walls. When I look, they're 3 by 2.5. So 3 times 2.5 would give me 7.5. But I don't just have one of those walls, I have 2, so I'm going to multiply it by 2, and that's going to give me 15. Okay, next step is I'm going to add them together. So I have 17.5 plus 15, and that's going to give me 32.5. And then now I'm going to read the question. So I know it's 32.5 meters squared of paint that I need. It says if 1 container of paint covers 10 square meters, how many containers should she buy to finish the job? So if she buys 1 container, that's 10. A second container is 20. a third container is 30, but it's 32.5. So 3 containers won't be enough. So she's actually going to need 4 containers of paint. And then she'll have some left over for touch-ups later. All right, let's try number 3. Sam's mom plans on making a tent for his upcoming camping trip. She has already purchased 20 meters of material. Look at the sketch below. Does she have enough material to finish the project? Show your work to justify your answer. All right, so we have all the measures that we need on here. Again, some of them are hard to see. So this is 2.3, this is 1.8, this is 1.6. Okay. And then look right here, this is important. It says the area of the windows is 1.5 square meters. So this right here and this right here, those are windows. So what we're going to do is, this is actually a triangular prism. I know that because it's got the 2 triangular bases and the 3 rectangular faces. So we're going to do our triangular prism formula or method of solving, and then we're going to take away the windows to see if she has enough. So let's see what we got here. We've got, let's start with our triangular bases. Okay, and we know all of these are exactly the same. So they're each 1.8. So right here, I know this is 1.8 for the base. So I'm going to say 1/2 times 1.8 times the height of my triangle. That's this dotted line, the altitude right here. That's 1.6. I'm going to put that in my calculator. And I get 1 44/100. But that's for one triangle, and I have 2 triangular pieces that match. So I'm going to say times 2. Again, we're ignoring the fact that there's windows right now. We're trying to figure out what it would be if it was just a solid tent. Okay, so there's my 2 triangular bases. Gives me 2.88 meters squared. Now I'm going to look at the rectangular part. So all these rectangles are exactly the same. I know that because they each have a width of 1 8/10, and they each have a length of 2.3. So I'm going to say my rectangle is base times height, so I'm going to say 1.8 times 2.3. And I find out just one of these rectangles is worth 4 14/100. But I don't have just one rectangle. I have 1, 2, 3 identical rectangles, so I'm going to multiply it by 3. And I find out just for the rectangular part, I have 12 42/100 meters squared. Now I'm going to add them together. To see what the total is. Oops. So I have 12 42/100 plus 2 88/100, and I get 15 3/10. Now it says that the windows take up 1.5 square meters, so I can take that away because she's going to use a different kind of material for the windows. And when I subtract, I get 13 8/10 meters squared is what she needs. It says she's already purchased 20 meter, it should say squared, that's deceiving, 20 square meters of material. So I would say, yes, she has enough. All right, let's try the next one. Natalie plans on winning this year's Valentine's Day box contest. She plans on decorating the inside and outside of her box by covering every surface with paper. How many square decimeters of paper will she need? Show your work to justify your answer. All right. So let's think about this. Let's think about what she's not going to cover. 1, there's not a lid to her box. So it's an open box. Picture like one of my Tupperware bins without the lid on it. That's what we're thinking here. And we're also not going to wrap the bottom of the box because it's sitting on the table. So that would be kind of silly to wrap that. So we're going to wrap the inside and the outside of the box. So that means when I'm looking at a side like this, not only does this rectangle match the rectangle that's back here, okay, but I'm also doing the inside and outside of it. So instead of multiplying it by 2, we're actually going to multiply it by 4. So I'm going to say the yellow rectangle, that would be 2 by 5, which I know is 10. So I have the front and back, the front and back. So I'm going to take that and multiply it by 4, which would be 40. Okay, then I'm going to say there's an orange rectangle over here, and that matches this orange rectangle over here. So the length and width of that would be 2 times 4, which is 8. But again, I have the outside and inside, that outside and inside. So I'm going to multiply that by 4, which is going to give me 32. Now I'm almost done. I have to also imagine that she would cover the bottom of her box right in here. She's going to cover that bottom portion. So that's just one rectangle, and that one rectangle looks like it's a 4 by 5 rectangle. So I'm going to do it like this. It's a 4 by 5 rectangle, which gives me 20. Then she will cover everything on the inside and outside. Remember, it doesn't have a lid, and we don't need to cover the bottom of the box. So I'm going to add them all together. I have 40, 32, and 20 that I add together. And I find out that she's going to need 92 square decimeters of wrapping paper. The diagram below shows a pyramid glued to the top of the cube. Given that the slant height of the pyramid is 5.9 centimeters squared, find the total surface area of the solid. Round to the nearest whole number. Show your work. All right, so I have a cube that has a pyramid glued to the top of it. So what that means is if I'm going to wrap my solid, I'm going to find the surface area of my solid, this square that is not only the top of the cube, but the bottom of the pyramid, that's not going to be visible to us. So we need to think about that when we're figuring this out. That top part of the cube, also known as the bottom part of the pyramid, you're not going to be able to see that. That would be on the inside of that three-dimensional object. So we're going to have to take that out. So let's start with our square faces. Okay, so I'm going to start with my square faces. So I'm going to say square. And I know my formula for that is side squared, or length times width. So that's going to be 6 times 6, which is 36. And then let's think about how many faces there are. There's the 4 surrounding it, 1, 2, 3, 4. And then there's the 1 on the bottom. Again, we're not including this one on the top because this one's in the middle of the object now. So we're going to say times 5. So 36 times 5 would give me 180. So that's covering the 5 square faces of my cube. Okay. Now, on our triangular pyramid, we don't have to worry about the base because, again, the base is on the inside of the figure, so that's not part of the surface area. We just need to worry about my 4 triangular faces, these right here. And there are 4 of them that are exactly the same. I know they're exactly the same because I have a square and all sides are the same on a square. So now I'm going to do my triangle, and I know that's 1/2 times the base. So the base of my triangle would be right here. So that's 6 times the height. That's this line going up that we were told was 5.9. So I'm going to say 1/2 times 6 times 5.9. It's going to give me 17.7. But I don't have one of those triangles. I have 4 of those triangles. I know there's 4 because there's 4 sides on a cube. I'm going to multiply that by 4. I get 70.8. So then my last step is to just add those 2 numbers together. 180 plus 70.8 is going to give me 250.8 centimeters squared. So that one's only tricky because we just have to remember that this square top is no longer counted because that's on the inside of the figure. We wouldn't be wrapping that with anything. All right, number 6. 1 can of frosting covers about 280 square inches. Is 1 can of frosting enough to frost the cake? Show work to justify your answer. So we have to think about something here. When we are frosting a cake, do we frost all sides of the cake? Well, the answer to that is no. You don't frost the bottom of the cake. Okay, so keep that in mind. We don't frost the bottom of a cake. So we can't use our smiley face method here because it's going to throw us off a little bit. We kind of just got to do one section at a time. And this is kind of hard to see because it's shaded in black. So I'm going to start by doing this front side right here. Maybe you can see that a little bit. I'm going to do this front rectangle, and I know that's going to match the back rectangle. Okay, so the front of my cake right here is going to match the back of my cake over here, and I know that's a 9 by 3 rectangle. I'm going to say 9 times 3 is 27, but again, I have one of those rectangles in the front, and then I'm going to have another one back here in the back that needs frosted. So I'm going to multiply that by 2, and I get 54. Okay, I have another side of the cake. I have this side over here. I'm going to put it in yellow. I'm going to kind of go on the outside so you can maybe see it. So that rectangle right here, I know it looks like 13 by 3. So I'm going to say that's a 13 by 3. That would give me 39, but I have one rectangle over here, but I have another one over here that's going to match it. So I'm going to say times 2. That would give me 78. And then I have to frost the top of my cake. The top of my cake needs frosted, of course. So the top of my cake is 9 by 13. And that's going to give me 117. Okay, so let's add it all together. I have the top of my cake, 117. I have the front and back of my cake, that's worth 54. I have the two sides of my cake, that's worth 78. Again, I don't frost the bottom of my cake, so that's not included. And when I add these all together, I get 249 inches squared. It says 1 can of frosting can cover 280 square inches. So do I have enough? I would say yes, I should be okay. Okay, and the last one, and some of these numbers are really hard to read. We really need to retype this. So I'm going to put the numbers in for you. This is 4, 12, 5, 5, and that's referring to that slant height right here. And that number right there is 7. So it says find the surface area of the composite solid, show work. Hint, 5 feet is the height of the triangle in the pyramid. So that's what that arrow is showing. So let's look here. I need to cover this figure, except I need to take out the bottom of this pyramid right here. The bottom of that pyramid isn't showing. So let's start with what we know. Let's do our triangular faces for our pyramid. Okay, so I have triangular faces, and I know the base right here is 5 for this triangle. Let's make sure that it's also 5 for this one. So this is probably the trickiest part of this. So I know from here to here is 12. I know from here to here is 7. So what would this be? So 12 minus 7 is 5. So yes, this is a square pyramid. Okay, so all of my triangles are going to be exactly the same. That's good to know. So I'm going to do 1/2 times my base of my triangle is 5, and the height of my triangle is 5. So that's going to give me 12.5. But there's 1, 2, 3, 4 triangles on this square pyramid. And that's going to give me that's what I thought. 50. Started right 48. Okay, so I know just the triangular faces, that's going to give me 50. Okay, so now let's start working on our rectangular prism part. So we have this face right here and this face right here. Okay, so I'm going to say rectangle that is yellow. That's 4 by 5. So 4 times 5 is 20, but I have 2 of them, so I'm going to say that's 40. Okay. Then I have these rectangles in the back and in the front. That matches this one up front. I highlighted the one in the back, but it matches the one up front. Right? That rectangle is 12 by this height right here, which would be 4. So my rectangle in orange, that again, I have 2 of them. I have the one in the back and the one in the front. So that's, what did I say, 12 by 4. 12 times 4 is 48. But I have 2 of them. I'm squeezing this in, which would give me 96. Okay, so I have 2 more parts yet I still have to do. I have to cover the bottom of this rectangle. Okay, so I have to do that bottom rectangle. That's 12 times 5. I'm going to say the rectangle that I straight beat in. That's 12 times 5, which would give me 60. Then I have one more little piece. I have this part right here, which doesn't match my bottom rectangle because of this pyramid that's sitting on top of it. So I need to do this blue rectangle that's formed because I placed this pyramid on top. I'm going to say the rectangle of the blue would be 7 by 5, which is 35. Look at all those pieces I had to do, guys. I had to do my triangular faces. I had to do these 2 yellow sides, the 2 orange sides that are front and back, the bottom, and this little rectangle right here. That's a lot to do. This would be a really great bonus question on your test. So now I have to add all those pieces together. So I have 50, 40, 96, 60, and 35 that I'm going to add all together to get my final answer. So 50 plus 40 plus 96 plus 60 plus 35 gives me a grand total of 281 feet squared. There you go. That's how we do it. We're going to practice a lot more composite figures and story problems this week, so don't panic if you're not understanding. I'm sure you'll get it by the end of the week.